Hello viewers, I give a very grand welcome to you all on my channel. The name of my channel is Positron. Positron. Positron is the actually antiparticle of electron. You know well about electron, proton, neutron. So this inspired me, this clicked with this name. So this inspired me to put the name of my channel Positron. My channel is dedicated to the physics completely 11th, 12th, NEET, JEE, all those who are the aspirants of competitive exams. Dear students, I will not boast, but I promise and I will try to keep my promise that the content of this channel must be up to the mark. Dear students, I am beginning my journey from unit and dimensions. Unit and dimensions. Actually, this very chapter consists system of units, fundamental quantities, dimensional analysis, and a very important topic, that is error analysis and significant number solver. In 2 or 3 videos, I will try to cover these topics. Dear students, my advice to you are, let's discuss something about the physics. If you want to know, if you want to read the good physics, then there are some basic instruments and you should know about these instruments if you are studying the physics. Very first, you should have a very good idea of graph. If you do not know much about the graph, then you cannot have a good knowledge of physics. Second one is vector. Without knowing the basics of vector analysis, you cannot solve the problems and numericals involved in physics. And third one is most important and instrumental while we are studying the physics. That is calculus. Calculus, I mean differentiation and integration. You also have a good knowledge of this calculus. So the 3 things I would like to cover after second or third video. My second or third video will be based on these topics. Graph, vector. In one video I will try to cover the graph. In next video I will try to cover the vector. And calculus not at the length but basic that calculus that is used in physics up to that only. Okay. So I will begin my journey with you all from unit and dimensions. Dear students, let's start the topic system first. System, physical units. Physical quantities are what? Those quantities which are measurable called to be the physical quantity. Those quantities which can be measured are called to be the physical quantities. Now let's talk about the system of units. Little friends, you know, in science and technology it is said that necessity is the mother of invention. System of units, the 3 kinds of system of units are used across the globe. The first one is MKS, that is meter kilogram second, or SI system, system de international. Second one is FPS, foot pound second, and third one is CGS, centimeter gram second. Dear students, how we discover the system of unit? What was the need of system of unit? The International Office of Weight and Measurement was established, I think, in 1888 or 1890s in Sevres near Paris, capital of France. You can ask that, was before the 1890 there was no unit? Now, there was unit. All parts of the world have their local units. Even in India, we have our local units before 1890. But you know, the 19th century was a century of business. It was a beginning of new era. It was a time of industrial revolution. It was a time of invention. It was a time of colonialism. The great power at that time were fighting to grab maximum colonies across the globe. So, many inventions taken place at that time, like the invention of steam engine, invention of telegraph, invention of telephone, and many steel plants were established across the world. So, what happened? If these all inventions need the market, and to do the business can grow only when there is a same system of units across the globe. So to fulfill that purpose, in 1890, Office of International Office of Weight and Measurement was established in Paris, Sevres. The three system of units are used. First is the MKS, meter kilogram second. It is also called System D International. Actually, it is derived from France, so this is System D International. It's a bit of French test. Second is the FPS, foot pound diameter. Even today, in Britain and France, FPS is used. And third one is CGS, centimeter gram second. Across the Europe, even today, centimeter gram second is used. There is a very famous book of physics that is called Resnick Holiday. If you will study that, in that book, there will be system of unit used is the FPS, foot pound second. Now let us move to us. Physical quantities. Dear students, the physical quantities can be divided into three types. One is a fundamental quantity. Second one, first is a fundamental, second one derived quantities. And third one, complementary quantities. These are 7 in numbers. Fundamental quantities are 7 in numbers. Complementary quantities are 2 in numbers. And derived quantities, except of these 9 quantities, all the quantities are derived quantities. Dear students, let us first start about the complementary quantities because they are numbered in two. Angle and solid angle. First is an angle and second is a solid angle. These two are said to be the derived complementary quantities. The unit of angle is radian and unit of solid angle is straight. Angle is what? That is between the two lines or between the two surfaces. Even between this is between the two lines, that is the angle, and between the two surfaces like this. This is the angle. So the unit of angle is a radian, and you know 180 degrees is pi radian. So 1 degree is equal to pi upon 180 radian. Whenever you are doing the calculations, Basically, you have to use the radian. Second one is solid angle. Solid angle has the unit steady. Dear students, I am sure the room in which you are watching my video, look at the corner of that room where the three surfaces are meeting to each other. That corner angle is a solid angle and the unit of that angle is steady. And I am sure you have enjoyed the ice cream, the cone ice cream. At the bottom of cone, the angle is a solid angle. So later on we will discuss also that how the solid angle can be defined. If you want to know, omega equal to a cos theta over r square. Okay, a is a area and r is a distance. But we will discuss next to it. Now it comes fundamental quantities. Let us do that. Let us discuss the fundamental quantities. Fundamental quantities. As you know, I'm sure even from 9th standard you are studying. I'm just trying to brush up your knowledge. Just to let you remember, because I'm sure you have studied all these. The first fundamental quantity is length, and its unit is MKS, unit is meter. Second fundamental quantity, mass, and its unit is phase. Third one is time, and its unit is second. Fourth one is length, mass, time, temperature, its unit is Kelvin. Fifth one is length, mass, time, temperature, electric current, its unit is ampere. Fifth one is amount of substance. Amount of substance, that is mole. And last one is that is a luminous intensity. That is Kelvin. These are the 7 fundamental quantities. Why they are called to be the fundamental quantity? Because in order to express these quantities, you have not to discuss other quantities. Or in order to discuss these quantities, it's not required to give the reference of other quantities. That is why these are said to be the fundamental quantities. Length, mass, time, temperature, electric current, amount of substance, and luminous intensity. Length, you are aware of it, I'm sure. Length has the unit meter, mass has kg, time second, temperature is a Kelvin, degree Celsius, electric current ampere, amount of substance mole, and luminous intensity Kelvin. Dear students, let us discuss one by one at length to these quantities. The first is the length. Standard unit, MKS unit is a meter. Now we have to define 1 meter. How you define 1 meter? Okay? There are number of standard definitions. The international standard definition, it is not a one but number of definitions. Some of them we have to discuss. The very first definition, distance traveled by the light. This 1 meter is the distance equivalent to distance traveled by light in 1 upon 299, 792, 458 seconds in vacuum. Means in this time interval 1 upon 299, 792, 458 seconds in vacuum light travels 1 meter, or 1 meter is the distance traveled by the light in vacuum in 1 upon 299, 792, 458 seconds. Second one definition is 1 meter is the distance equivalent to wavelength of 1 meter is the distance equivalent to 1650,763.73 times of wavelength of orange color wave emanating from krypton 86. Dear student, this is another definition. You know the inert gases above, the 6 inert gases: helium, neon, argon, krypton, xenon and radon. So 1 meter is the distance equivalent to 1650,760.73 times of wavelength of orange color wave emanating from krypton 86. So there is the inert gas krypton 86. From this orange color wave comes out. So 1 meter is equivalent to this much times of wavelength of that orange color wave. You may ask that what is wavelength? I am asking you what is wavelength. This is one pulse of the wave. This is one pulse of the wave, and the length of one pulse is called wavelength. One length of this one pulse is called wavelength. Also 1 meter has been defined as there is a rod made of platinum and iridium kept in Savier's Paris, and there are 2 marks on this rod at 0 degrees C. The distance between these 2 marks is said to be the 1 meter. Again I am repeating my sentence. Dear students, there is a rod made of platinum and iridium kept in Savier's Paris, and there are 2 marks on the rod. The distance between the 2 marks at 0 degrees C is also said to be 1 meter. Why do we, now the question will be that why do we consider platinum and iridium alloy? Why don't we consider another alloy? Simply because coefficient of linear expansion for platinum and iridium alloy is a very little. So with the change of weather, there is very less chances to change the length of the rod. So there will be negligible change or there will be no change. That is why throughout the year in every season it will be same. That is why we consider platinum iridium alloy for making 1 meter. Actually, in India, in our country, these distances are measured. There is a prototype of that rod is kept in NPL National Physical Laboratory, Delhi, and the distances, weight and lengths are measured from NPL. And all the meter sticks that are used in the market even today, that comes are derived from NPL National Physical Laboratory, New Delhi. Now, this was the 1 meter I have discussed with you. Let us talk about the small units of length and bigger units of length. Small units are what? The smallest one is a Fermi. 1 Fermi is equal to 10 power minus 15 meters. Fermis are physicist, great physicist, has so much work in atom and nuclei. Actually, Fermi is the smallest unit to measure the length, and this range of unit, this order is used in measuring the atom or nucleus diameter. Then it comes when picometer, that is 10 to the power minus 12 meter. Then comes one angstrom, that is 10 to the power minus 10 meter. Then comes one nanometer, that is 10 to the power minus 9 meter. And then comes one micron, and that is 10 to the power minus 6 meters. These are, as I have told you, that these are the smaller units of length that is used to measure the dimensions or diameters of atom, nuclei, or the dimensions of different viruses, bacteria like amoeba, paramecium, and so on. Now let us talk at length to the bigger unit. These have been the smaller units or smallest unit to measure the length. Let us consider the bigger units used to measure the length. First one is a very important astronomical unit, AU. This is equivalent to 1.496 into 10 raised to the power 11 meter. Dear students, while you are studying the physics, it's my advice to you. That sometimes you have to remember the data. Even a normal person, even a normal student nowadays have at least 20 mobile, 10-digit mobile numbers. You remember. So why don't you try to remember the data of physics? And if you have a good knowledge of data, then you can compare the things. You can compare the system. As I told you, AU, it is called astronomical unit. Astronomical unit. And that works out to be 1.496 into 10 to the power 11 meter. Dear students, it is the average distance between the Earth and Sun. That is equal to 1 AU equal to 1.496 into 10 to the power 11 meter. And I have said that this is the average distance between the Earth and Sun. Like this is the Sun, and Earth is revolving in a particular orbit around the Sun. This is Earth, and this radius of this orbit is equal to 1 AU, and this is equal to 1.496 into 10 to the power 11 meter. Dear students, in gravitation, while you are studying the topic of gravitation, you will come to know that this orbit is not circular actually. Earth is not revolving circular orbit around the Sun, but orbit is elliptical, and sometimes Earth is closest to the Sun and sometimes farthest from the Sun, and these two conditions are said to be the Parisian apogee. That we will discuss later. So it is that's why I am continuously saying that this is the average AU, astronomical unit, is the average distance between the Earth and Sun. That works out to be 1.496 into 10 raised to the power 11 meter. Now comes another bigger unit to measure the bigger length. That is a light year, 1 light year. That is simply light year. By name is clear. The distance traveled by light in 1 year is called to be the 1 light year. The distance covered by the light in 1 year is called to be the light year. So, how do we define 1 light year? That is, the distance is equal to velocity into time. Velocity of light in vacuum is 3 into 10 raised to the power 8, and time is a 1 year. 1 year means 365 days. Okay, every day has a 24 hours. So now you have converted it into hours, and then 60 turn into minute, and finally it is, if you multiply by 60, then it turns into second. And if you solve, you will get the answer 9.46 into 10 raised to the power 15 meter. 1 light year. This is. Now the question is that where these units are used. These units are used to measure the distance between the stars, between the planets and so on. Now the question is that whether this is the biggest unit to measure the last distance? No. Even there is a unit bigger than this light here. That is said to be the parsec. 1 parsec. Parsec. It is also called parallactic second. Parallactic second. This works out to be 3.08 into 10 to the power 16 meter. Look here. The light year has the order 10 to the power 15 meter. Or you can suppose it also to be 9.46. If you suppose it to be 10, then this order is nearly 10 to the power 16 meter. And what it is 3 into 10 to the power 16 meter. So parsec is approximately 3 times bigger than the light year. The parsec is 3 times bigger than the light year. So the biggest unit to measure the length between the stars or between the planets, that is parsec, that is parallactic second, and 1 parsec or parallactic second is equal to 3.08 into 10 to the power 16 meter. Number of times in NEET has been asked that parsec is the unit of, then the options are mass, time, length, something to do. Suppose that is actually to pass a parallactic second. So people do suppose that it is a unit of time, but it is not so. It's a unit of length, and it is the biggest unit to measure the length. Now, like light year, you have defined that the distance traveled by light in 1 year is second. Now we have to define 1 parsec. Dear students, this is an arc of 1 astronomical unit. 1 astronomical unit, I have told just few moments earlier, 1.496 into 10 to the power 11 meter. Right? This is 1 second. And this t is called to be the 1 parsec. 1 parallactic second. I have told you that parsec is the unit of distance. Now, how we can define 1 parsec? The distance at which arc of 1 astronomical unit length, arc of 1 astronomical unit length makes an angle 1 second is called to be the parsec. The distance at which the arc of 1 astronomical unit length makes an angle 1 second is called to be the 1 parsec. Dear students, we have to convert this into a radian. I have told you that 1 degree is equal to 60 minutes, that is equal to 3600 seconds. 1 bar represents actually minute and 2 bars second. So 1 second is equal to 1 degree or 3600 1 upon 3600 degree. Or if you are to convert into radian, how you can? 1 second is equal to 1 upon 3600 and multiply by pi by 180. Because 180 degree is equal to pi radian, so much degree is equal to pi upon 180 into this. Okay? So you have got the value of 1 second into radian. Now apply the very simple formula, you know, since 9th standard, that angle is this much, 1 upon 3600 into pi upon 180. Angle equal to arc is a 1.496 into 10 raised to the power 11 upon length is a d, and you have to find out this d. This works out as a 1 parsec. So d is equal to 1.496 into 10 raised to the power 11 into 3600 into 180 over pi. D is equal to approximately value I am trying to find because it's too much time, not at too much time yet, please. So 1, 2, 3, it will become 10 to the power 40, 1.496 into 10 raised to the power 40. This is 36 into 18 over pi is 3.14. So take this 1 apply here the point, it will be 10 power 15. Just cancel it approximately, and 10 power 15, then you will multiply 18 by this 1.5 actually, so you will get this is 27 nearly, or the d is equal to, I have got 27 into 10 power 15 meter, or d is equal to 2.7 into 10 power 16 meter. It is an approximate calculation, but exact calculation result into d equal to 3.08 into 10 power 16 meter. And you know, in case of light year, 1 light year is equal to 9.46 into 10 power 15 meter. Dear students, just compare the order of these two units. It is, if we suppose it to be 10, then it is 10 to power 16 meter. So parsec is a 3 times greater than the parsec is a 3 times of light year of distance. Now let us move to the second unit. That is the second unit is the mass. How will you define? The unit of mass is a kg. Dear students, we have to define 1 kg. The international definition of 1 kg. That is a very important definition. That mass of 1 liter pure water at 4 degrees C is equivalent to 1 kg. This is also an international definition, that mass of 1 liter pure kg at 4 degrees C. Mass of 1 liter pure water at 4 degrees C is 1 kg. Dear students, why do we consider 4 degrees C, not 0 degrees C? Because water has an abrupt behavior. Water is a bit of different liquid. Just below 4 degrees C, when water is going to, at 0 degrees C, water is converted into ice, and when water becomes into ice, when water turns into ice, the density of ice is less than the water. That is, this is called the abrupt behavior. The density of water is maximum at 4 degrees C. Why 4 degrees C is important? That density of water at 4 degrees C is maximum, and this is the why the fish, even in extreme cold, at the surface, despite the lake is freezed at the top, but below the top there is a water in which the fishes are alive. Now there is another definition that is said that there is a cylinder made of platinum and iridium alloy kept in a aqueous space, and the mass of that cylinder is also 1 kg. Dear student, this is a prototype actually, and this is consisting 90% of platinum and 10% of iridium. For your kind information, I can use the data. This cylinder is consisting actually 90% of platinum and 10% of iridium. So the mass of that prototype cylinder made of platinum and iridium kept in a aqueous is also 1 kg. Dear students, if you want to measure the masses of atoms or nuclei, then kilogram is not a relevant. So what is relevant? The relevant unit is that is called the AMU, atomic mass unit. 1 AMU is equal to 1 by 12 into mass of 1 carbon 12 meter. AMU, or it is simply written as 1U, that is atomic mass unit. This is used to measure the mass of molecules, atoms, nuclei, so on. So AMU is equal to 1 upon 12 into mass of 1 carbon 12 atom, and if you solve, you will get 1.67 into 10 power minus 27 kg. Dear students, I have told you always what it was my advice that sometimes we should remember the data, and if you know the data, about, then you can compare the physical system very good. Like the mass of Earth, the order of mass of Earth is 10 to the power 25, whereas the order of mass of Sun is 10 to the power 31. So how many times is bigger the Sun is in compared to Earth? You can just compare. Now that was a mass. Coming to the third unit, third fundamental quantity, that is a time, and this international unit is seconds. Now we have to define the 1 second. 1 second is time in which cesium-133 atom completes 9, 192, 631, 770 vibrations, 770 transitions in its hyperfine structure. Hyperfine structure. Dear student, there is about hyperfine structure. I am just discussing. 1 second is a time in which cesium-133 atom completes 9, 192, 631, 770 vibration, 770 transitions in its hyperfine structure. Hyperfine structure is in higher study you will study, but you know the electrons are revolving in different orbits around the nucleus, and the orbit is further divided into suborbit, and suborbits are further divided into sub-energy levels. So a single orbit has many possible energy states, and the atom might move from one level to other level, and this is called hyperfine structure. Right? So division of sub-energy levels into number of energy states is called hyperfine structure. So 1 second is the time in which cesium-133 atom completes 9, 192, 631, 770 vibrate transitions in its hyperfine structure. The fourth one, dear students, was temperature. Now we have to define the temperature. It's SI unit is either Kelvin or degree Celsius. You may write Kelvin or Celsius. Dear students, how will you define that? I am taking Kelvin, and how will we define the Kelvin? 1 Kelvin is defined as 1 upon 273.16 times of triple temperature of water. Now the two was this is triple temperature. Triple temperature is what? How will you define triple temperature? The temperature at which water exists in all the three states together is called to be the triple temperature. So 1 Kelvin is defined as 1 upon 273.16 times of triple temperature of water. Dear students, as I said that what is triple temperature? The temperature at which water exists together in all the three states, solid, liquid and gas, is called to be the triple temperature, and actually that is a 0 degree C, and 0 degree C is equal to, you can use the conversion formula. If there is a temperature given in Celsius, if you add 273.16, you will get the Kelvin. Dear students, actually, if you will replace a 0 degree C, then you will get 273.16 Kelvin. So you can say the triple temperature of water is either 0 degree C or 273.16 Kelvin. So triple temperature of water is 273.16 divided by 273.16 results in 1 Kelvin. Dear students, another unit of temperature is degree Fahrenheit, that is used by our doctors How you can relate f minus 32 or 9 is equal to c by 5. You can prove this also, it's a basic, nothing is very important, especially let unknown temperature at Celsius scale is C, then it becomes C. What is the freezing point at the Celsius scale? Freezing point of water is 0. Now divided by what is the boiling point of water? 100 minus freezing point of water again 0. On Fahrenheit scale, how it is? Now it says boiling point is 212 minus freezing point is at 32, and so it is now look here. And let the unknown temperature is on the Fahrenheit scale is F, then F minus freezing point is 30. What I have done, I am trying to clear it to you again. Dear students, let the unknown temperature on Celsius scale is C, then C minus the freezing point of water at Celsius scale, that is 0, so C minus 0 divided by boiling point minus freezing point at Celsius scale, 100 minus 0. Now here, let unknown temperature at Fahrenheit scale is F minus freezing point on Fahrenheit scale, the freezing point of water is 32 upon boiling point of water on Fahrenheit scale, that is 212 degree Fahrenheit, minus freezing point of water on Fahrenheit scale, that is 32. So you will get F minus 32. If you solve this, you will get 180 for C upon 100. So actually it is what? Between boiling point and freezing point of water at Celsius scale, there is a 100 division and each division is equal to 1 degree C. And similarly, you can say between the boiling point and freezing point of water at Fahrenheit scale, there is a 180 degree Fahrenheit and each division is a 1 degree Fahrenheit. So if you cancel it, 25 which are 29, so F minus 32 upon 9, that is equal to C by 5. So in this way, you can convert Celsius into Kelvin, Celsius into Fahrenheit, and Fahrenheit also can be converted into Kelvin. First convert the Fahrenheit into Celsius and then Celsius into Kelvin. Now here students, what I am going to tell. The normal temperature of human bodies, normal temperature of human bodies human bodies 98.6 degree Fahrenheit. Convert it to Celsius. It's homework to you. Solve it. F minus 32, F is this, minus 32 upon 9, that is equal to C upon 5. Find out the value of C. That works out to be 37 degrees. Now, next is the fourth is electric current. The unit of electric current, the SI unit of electric current is 1 ampere. You know, I is equal to, even intensity standard, you must have gone through. I is equal to Q upon T. Or you may write 1 ampere is equal to 1 coulomb divided by 1 second. So, you can say that 1 ampere current is what? If from a point 1 coulomb charge passes in 1 second, then the current flowing is 1 ampere. If the 1 coulomb charge passes in 1 second from a point, then current flowing would be 1 ampere. But dear students, this is not a standard definition. The standard definition is a bit different. Let the two long straight parallel wires. We have considered the two long straight and parallel wires, and they are kept at 1 meter distance away. And at per unit length, they are experiencing a force of 2 into 10 to the power minus 7 Newton, either attractive or repulsive. Then the current flowing will be 1 ampere. Again, I'm writing the definition, very important definition. If the two long, straight and parallel wires are kept 1 meter away and at per unit length they are experiencing a force of 2 into 10 power minus 7 meter, then current flowing in wires will be 1 ampere. Dear students, if the current in the two wires, in two parallel wires is flowing in the same direction, then the force will be attracted. And if the current flowing is in opposite direction, then the current will be, then the force will be repulsive. The fifth, let's consider the fifth one. It amount of substance dear students, I think it is not fifth, it's the sixth amount of substance. It's a SI unit, it is a mole. Now we have to define 1 mole. How will you define 1 mole? 1 mole is equal to number of entities that is equal to number of carbon 12 atoms in 0.012 kg of carbon. What is said? 1 mole is equal to number of entities that is equal to number of carbon 12 atoms in 0.012 kg of carbon. Dear student, what does mean entity? Entities are actually means, let you are considering 1 mole atom. Then 1 mole atom is equal to the number of atoms. 1 mole atom is equal to number of atoms that is in 0.01 kg of carbon 12 atom. Or simply let 1 gram 1 mole molecule, then like 1 mole atom is equal to Avogadro's number, and you know Avogadro's number is 6.023 into 10 to the power 23. In similar way, 1 mole molecule that is again is equal to Avogadro's number. So 1 mole is equal to number of entities that is equal to number of carbon 12 atoms in 0.01 kg of carbon. And the last one is that is 7th and last one, that is luminous intensity. Candle. How will you define the one candela? Luminous intensity are right like this. One candela is defined as luminous intensity in a particular direction, if it emits monochromatic radiation of 514 to 10 power 12 hertz, 514 to 10 to power 12 hertz, and in that direction radiant power is 1/683 watt per steradian. Dear student, this is the way you can define the one candle. One candle is defined as the luminous intensity of source in a particular direction if it emits the monochromatic radiation of 514 to 10 power 12 hertz, and in that particular direction the radiant power of the source is 1/683 watt per steradian. Dear students, nothing more you have to know about the luminous intensity at this stage. At a glance you can say that luminous intensity is actually, it represents the brightness of a source. Now it comes monochromatic radiation. What do you know about monochromatic radiation? By the name it is clear that a light of single color. But actually it is not so. Dear students, you have gone through the rainbow, you have studied, that is width 0. The 7 color components of rainbow, that is width 0. Now this is violet, indigo, blue, green, yellow, orange, red. Now red, this spectrum ranges from 4000 angstrom to 8000 angstrom. This spectrum is only visible to a human eye, means this is only sensible to human eye. Now red is 8000 angstrom. So does it mean that red 8000 angstrom wavelength wave is only red? Actually it is not so. The red color begins from 7600 to 8000 angstrom. So between the 7600 to 8000 angstrom, every wave has a red color. But then you cannot say it is a monochromatic. Monochromatic means that two waves which have the wavelength in the vicinity of each other, means their wavelength is slightly close to each other, or the difference between the wavelength is a very little. For example, let light you have considered for red color 7700 angstrom, and there is a 7701 angstrom, right? And there is a 7702 angstrom. So these three lights which are having the wavelength 7701, 02, 03 can be said to be the monochromatic radiation. Thank you, dear students. If you think that my videos are going to be beneficial to you, then please and please share, subscribe and comment. Thank you. Meet you in next video. Till then, bye.